Hello and welcome to the lecture 4 of the Learning About Learning course. And in the last lecture, we talked about the various associative rules that govern the strength of association when it is formed in an animal, right, in response to learning. Mainly, we talked about how the probability of a US occurrence given a CS or happened, and the probability that the US will occur given that the CS has not occurred. Okay. So, the associative strength depends on both these probabilities, the probability that the US will occur in the presence of CS given that CS has occurred, and the probability that the US can occur in the absence of CS. Both of them together determine a fundamental quantity called contingency. We said that determines the associative strength, and we showed we talked about an experiment done by Rescorla, wherein he introduced the notion of positive contingency, zero contingency, and most importantly negative contingencies. I said the existence of negative contingency is a direct proof that it is the contingency, that is the probabilities of the US occurrence given in the presence and absence of CS that governs the associative strength, and not just a simple co-presentation of CS and US. What other thing can actually determine the associative strength? Let us step back a little bit and look at what association are we talking about. The association here we are talking about are between two stimuli, right. These are any environmental factors, any sensory information that comes into an animal that have some unique properties. We classified them as unconditional stimuli and conditional stimuli based on their ability to elicit a response by itself or not being able to elicit a response. Now, if you think about what use thus an association will have for an animal when you are talking about making this association between these stimuli, clearly it boils down to survival, and somehow this learning has to help the animal to survive in the environment in a better way. So, in this context, it is a little bit naive and simple to assume that every unconditional stimuli is equally probable to associate with a conditional stimuli. This may not be the case, and it is not the case. If it is not the case, can we do an experiment to actually check it? Now, Garcia and Koelling set out to do this. They did that using the etiological behavior exhibited by the rodents. One of the important vital tasks for the rodents is to be able to expand their food palate, right. So, if you think of a rodent, the rodent's survival ability depends on their ability to find the food from various different sources, and they go ahead and get the food from burrows, undergrounds, and so on and so forth. It can be a huge menace, and people try to get rid of the rodents through various different means. One of the important characteristic that Garcia and Koelling made use of is called as bait shyness. What it means is, during this process of trying to exterminate these rodents, what people discovered is that when you present a poisoned food, right. So, you take some amount of food that you know that the rodent is fond of, and you mix a little bit of poison you poison that food and then present it in a place where you suspect the animal is actually coming and eating the food. It does not seem to work that well. The reason being, what I call in a very jovial fashion, the rodents are as smart as the human beings too. They learn that this is a poisoned food, I should not be going and eating that. How do they learn? what they do is that by nature if there is a novel flavor that is present, they are a little bit aversive towards eating that novel flavor completely. They go ahead and eat a little bit. They do not want to avoid altogether, because if you avoid altogether you reduce your palate. There is no scope for expanding the food palate. So, you want to keep that ability to expand it, right. So, you want to try out a little bit. If it causes a sickness or some kind of a malaise, you do not want to go and eat that. What these two people, Garcia and Koelling, noted is that this kind of a malaise tends to be associated with the flavor more than anything else. Anything else here means the animal does go back to the same place and in search of the food. They eat the other food, but not the poison food. That is the key here. The key is you can actually see the danger or the aversiveness of a particular flavor, a particular food is associated more easily to the flavor and not necessarily to the place. Clearly, if you do, if the animal goes back to the same place again and again, and all kinds of flavors do end up having poison, they will not go there. Clear, it is not that they can't make an association with the place at all, but instead what it turns out is that the inclination to make that, or the threshold to make that association, is higher for certain stimuli such as space compared to stimuli such as flavor. All right. So, how would you test it in a laboratory setting? What they did is that they took these animals and then trained them. They call it as tasty water or bright and noisy water. So, what it amounts to is that the rat here is allowed, they are water deprived and they are allowed to lick on a spout, and in response to that lick multiple things happen. One is that the water droplet comes in. This water droplet could be flavored, you call it as tasty water, or in response to that lick there is a flash of light along with a noise that triggers on into the chamber. So, whenever the animal gets a taste, flavored water, they called it as a tasty water stimuli, and whenever you get a flash of light and a noise, you call it as a bright and noisy water stimuli. After training them in this scenario for a few days, where they acquire their ability to actually go and then lick on that spout of the water to take this water, they asked now, hey look, I am going to take this as my conditional stimulus and then try to pair it, all right, pair it with different kind of stimuli. Okay. I am calling them as US. So, naturally they are having an ability to elicit a natural response. For example, X-ray here is known to cause a stomach malaise. If you take an animal and then X-radiate in certain dosages, they can cause gastrointestinal disturbances and nausea. So, the animal does not like that. I mean, it is a discomfort that they tend to associate with is known to associate with food, are similar to that of the discomfort that is caused due to the bad food. Lithium chloride, again the same thing, it causes stomach upset. Even though it tastes pretty much like sodium chloride, it is the salty water, it is known to cause similar stomach upset. The other uses are a quick shock. Okay. Inside this cage there is a floor or a grid of steel rods. What they have done is they have wired up to these steel rods such that whenever the animal licks on that spout, if required, one can present electric shock, a mild electric shock. You can do that right away or in a little time later. So, they called it as quick. In their paper they refer to as immediate shock. Okay. I am going to reserve that immediate word for something else, which the effect of which they do not know about in 1966. So, what I am going to call them or rephrase them as quick shock. Okay. Their shock is delivered reasonably immediately. Okay. The other option is that you delay that delivery of the shock a little later. So, clearly there are different kinds of uses, each of them can elicit the response, but they are different kind. So, the idea here is I am going to take this and then combine with this, take this, combine with this or any of this, and then ask how well does the animal associate. Or remember, when I say how well an animal associate, we are talking about a CS acquiring an ability to elicit a response, all right. The elicit a response independent of US, that is what we call it as an association. Okay. So, I want to make sure that is clear. In here there could be different kinds of responses, but the point here is whatever the response that we are talking about, that response did not happen before the CS is presented along with the US. Okay. CS once you presented it, the response develops, and how well is that response developing, that is what we are measuring. Good. So, what did they observe? They went ahead and did this pre-training, which is a training in which the animal is presented both this flavored water and the plain water, which is the bright noisy water they called it, and asked is there any difference between the flavored versus the bright and noisy water. So, they do that by two kinds of tests, which one they call it as gustatory test and the other one they call it as audiovisual test. It is nothing but you can take it as audiovisual test is when the animal is kept inside the chamber, it is going to lick, and in response to that lick plain water is going to happen and you have a flash of light along with the tone. Okay. Gustatory test is when the animal is going to get a flavored water in response to its lick, all right. What you see is that they are both equally preferred. It is not the amount of water intake is pretty much similar. So, how do they measure it? The measure that you see on the right hand side, I mean on the left hand side axis, is from an electronic glycometer. It actually measures how many licks the animal is doing per unit time. In here it is per minute, and you can see the rate of licking is pretty much the same for in both the tests. This is before taking this US and then pairing with any of the CSS. So, for pairing with different USs, there are 4 different options we have talked about, and let us look in. So, there are 4 different groups of animals they were using. So, let us look at one of them, which is X-ray. When you do that, you get when you are again looking at 2 kinds of animals here. The animals with the squares here represents the animals which do not have any reinforcement, which do not have any X radiation. Okay, just you are taken and then the animals are brought back after 3 days to the same chamber. Again you measure it, brought back to the same chamber, again you measure it. But these animals, the circle animals, so these guys, all right, those guys are the groups which in between these time underwent an X-ray radiation treatment, which means the next time when they come in, they tend to take less amount of water. Okay. Clearly here they are presenting only the flavored water in response to their licking, and they are progressively taking lesser and lesser amount of water. Now, what they want to ask is, I am going to now test, having exposed these animals to this training paradigm wherein you can lick, in response to the lick I am getting a flavored water. After this exposure these animals are taken and then given an X radiation that causes stomach malaise, and they waited for about 3 days. The reason why they waited for about 3 days is to let the animal recover from any malaise that is induced by this X radiation, and then let us see how their memory gets encoded or association gets developed. All right. So, you do that. Now, I am going to test it. How I am going to test it? I am going to bring the animal back to the chamber and then offer them these 2 choices, flavored water, all right, and do this audio visual test too. And what you see clearly is that they associated the in the post test they have associated the X-ray radiation stimuli with the flavor, as you can see from the gustatory test. So, when you are testing, you are provided with the flavored water or a bright and noisy water. So, if you are checking for the bright and noisy water, they are good. If you are checking for the gustatory, I mean flavored water, they are not drinking that much water. Now, they said this is all good. What if I go with this, what you kind of expect, right? Now, what if I go with compound stimuli? All right, they had to do that because if they were to combine the CS with different kind of shocks we are talking about, the quick shock or the delayed shock, then this has to be contingent on the animal's response, right. If the animal does not go and lick on the plain water, I mean on the spout with the bright and noisy water, you can't deliver a shock, right. So, there they in this combination, the way the experiment was done is the apparatus consisted of two spouts now. A spout which can deliver, let us say, bright and noisy water, and the other spout that can deliver the tasty water. Once you do that, then you can actually ask, you can combine them and then ask, hey look, how well do they do in the pre-test, and you give a shock. When you do a electric shock, they tend to associate this electric shock more with the tone or the bright and noisy water than the flavored water. So, you can see here the amount of consumption of the bright and noisy water has come down compared to this, while that of the flavored water stays exactly the same. Clearly, the electric shock has a higher propensity to be associated with the auditory and the visual stimuli than the flavor, right. Because you see, every lick during the acquisition phase, every lick in these animals produced an electric shock. So, they could have easily associated with the flavor or the tone and the light, but that when you are actually pairing them with the shock, what you see is that they associate more easily to the electric shock, the tone with the electric shock, suggesting that different USS have different propensity of association with the CS. Though from this paper it is not very clear the exact details of X-ray irradiation experiment, but later studies have shown that you can actually combine the lithium chloride group, right. So, you see here in our experiment you can combine this lithium chloride group, what they call it as a salty water experiment, along with the shock. So, now you have a possibility of compound stimuli and multiple USS, right, and then ask, hey look, what is happening here, and the results described in this paper you can you see that stomach mallease, the US of stomach mallease has a higher propensity to be associated with CSS of taste, while the electric shock has a higher propensity to be associated with the US of CS of tone and light. The point that we want to drive across is that not any two stimuli cannot be associated in all degrees, right. They have different propensities. Some of them have a easier association, and some of them can form association easily, while the others require a higher number of trainings or have a higher threshold. That being said, we have now addressed two of the criteria that determine the associative strength. One is the contingency, number two is the nature of the US and the CS. Third, and one of the most important experiment that really determined the basis of the framework that we are planning to develop here for understanding the associative strengths in learning and memory is done by Kamin. His question was, what role does prior learning play in a compound stimuli presentation? So, in order to address that, he was doing this experiment wherein there is a tone and a light used as a compound stimuli and then associated with a shock. When you do it time and again, what he realized is that both later on what you can actually do is, this is the training phase. Later on you can go into the testing phase. During the testing phase you can either give a tone and ask what is the response, or you can give a light and ask what is the response. What he found was both of them show a similar amount of learning. Both tone and light is capable of forming or developing a response when paired with a US of shock, electric shock. In this another group, what he did was he pre-trained the animal, wherein he presented the tone and the shock repeatedly until a point where the tone by itself can elicit a response. Took these animals and then presented them with the compound stimuli having tone and light together. Idea here is, if the animals have learned this tone and shock pairing before, now does it help or hurt the association of light and the shock when presented together? What he saw was that when you do it after pre-training, the light could not develop a response, could not form an association with the electric shock at all. Now that was an astounding result, because what you see is that it is not that the light by itself cannot form an association, but the light, whether the light will form an association in a compound stimuli or any stimuli for that matter will form an association, depends on the rest of the ability of the rest of the stimuli to elicit a response before itself. Suppose if I had trained the animal in light and shock, granted it is little bit harder, but if you can do that, and then did this same experiment, the prediction here is tone would not be able to form an association with the shock. So, whether in a compound stimuli, why would an animal pay attention or develop a new response if it already knows one of the stimuli is going to get associated? Maybe that is why it is not forming a new association. That was the reasoning Kamin was giving. While such a kind of reasoning are very useful and insightful, it would be more purposeful and useful if you could develop a framework, a mathematical framework, a description that can encompass all of these observations and maybe allow us to make new predictions that would not have been possible without that framework. So, what I am looking for is, or what I am going towards is to, how do we summarize all of them in a nice crisp mathematical descriptive manner, a mathematical framework, through a mathematical framework that gives you a description which can explain Kamin's experiment, Garcia and Koelling's experiment, and Rescorla Wagner's Rescorla's positive, zero and negative contingencies. Rescorla and Wagner, two of the prominent scientists, went ahead and developed these framework. What we will do is we will just take a glimpse of the framework, and then in the next lecture we will see at length what this framework is all about. The framework goes as follows. They said, looking at all of these observations, there seems to be a maximum amount of associative strength that the animal can develop, and this seems to be dependent on the US. All right. If it is an electric shock of a particular current strength, then that has a Vmax of say 0.4 or 5 or some unit there. If that electric shock changes in current value, then the Vmax will change, but then for a given strength of the electric shock, that is the maximum amount of learning, no matter how many times you keep repeating it. Once it reaches there, it just stays there and it saturates. Second, they realize that the amount of learning in each exposure, right? You are not learn. I mean, many times we don't learn in one trial, right? We keep repeating it again and again. In such case, we want to know, when we repeat it again and again, many number of trials as we proceed forward, how much is the learning, how much is the contribution of this trial to the learning. So, that they said is dependent on a quantity that they defined as a surprise, and the maximum amount of learning here is directly proportional to the surprise. That is the statement here. So, the surprise is quantified by the difference between my response at this point in time and the response that I could have at max, right. So, for every US I can develop a response, every US strength I can develop a response to a particular strength, right. That is what this first hypothesis or first assumption is. Let us call that as Vmax, and surprise is simply my response difference the Vmax. To be precise, it is defined as Vmax minus Vt, where Vt is my present response. The sign is important here. If you depending on that, you can learn, you can increase your response or decrease your response. We will see that in when we talk about specific examples. And the third main thing is that when you are presenting a compound stimuli, right, like the stimuli of Kamin's, right, tone, shock, or stimuli of Garcia and Koelling, flavored plus the bright, shiny, bright, nice, noisy water. So, in such cases, the compound learning is a sum of learning from individuals, or in other words, whatever the learning that gets incurred in a compound stimuli is distributed among the different CSS. Okay. So, let us keep that in mind, and when we come in the next lecture, we will precisely state what this in a mathematical form, and then through few examples we will see how Rescorla Wagner model, the model that we are proposing to state there, has explained things that are apparently non-intuitive in a very tractable and a possible way. The hope is after that I would be able to highlight some of the predictions that would not have been possible just by looking at individual experiments, the predictions from Rescorla Wagner. Thank you.